Hello mga ka-tribes! Welcome to Daddy Brew TV. For today's video, let's have general mathematics test. The question is, determine the domain and range of the following functions. Example number 1, 3x minus y is equal to 4. Now, for our solution, first, solve 3x minus y is equal to 4 for y in terms of x. So, bring down negative y is equal to transpose 3x to the right. That is now equal to negative 3x. Bring down positive 4, so that's plus 4. Then, multiply by negative 1, both sides of the equation. So, negative 1 times negative y is positive y. So, negative 3x times negative 1 is positive 3x. Positive 4 times negative 1 is negative 4. Now, it is now in the form of y. This y in terms of x. Okay? Since y is a polynomial, the domains is all values of x such that x is an element of all real numbers. Okay? Now, what about the range? So for the range, first, solve 3x minus y is equal to 4 for x in terms of y. X in terms of y. That is now equivalent to 3x minus y is equal to 4. Bring down 3x, transpose negative y, that is positive y, is equal to plus 4. Then divide by 3 both sides. So we have cancel this out. We have x is equal now to y over 3 plus 4/3. Or this also can be rewritten as 1/3 y plus 4 over 3. Again, take note that the given function is a polynomial without restriction. Okay? So therefore, the range of the function is all values of y such that y is an element of all real numbers. Second equation. The equation is y is equal to x squared minus 4. The equation is already expressed for y in terms of x, right? Since y is a polynomial, its domain is the set of all values of x such that x is an element of all real numbers. Now, to find the range, let's solve for y equal to x squared minus 4 for x in terms of y. So the equation is y is equal to x squared minus 4. Solving for x in terms of y, we have x squared is equal now to y plus 4. Then, solve for x, we have extract the square root both sides. We have x is equal now to the square root of y plus 4. This is positive, negative y plus 4. For x to be real, the radicand y plus 4 must be greater than or equal to 0. That is why y plus 4 is greater than or equal to 0 implies that y is greater than or equal to negative 4. And so, the range is all values of y such that y is greater than or equal to negative 4. Third example. The problem is 3y minus xy is equal to 2. Okay, for our solution, again, solve for y in terms of x. So the given is 3y minus xy is equal to 2. On the left side of the equation, we have a common factor. Okay, so we will factor the left side of the equation. Common factor is y, and then 3y divided by y is 3 minus xy divided by y is x is equal now to 2. Then let's solve for y. Divide both sides by 3 minus x. Cancel this out. So we have now y is equal now to 2 over 3 minus x. The obtained equation is a rational. So the denominator 3 minus x cannot be equal to 0. So 3 minus x is not equal to 0. Therefore, negative x is not equal to negative 3, or let's simplify, x now is not equal to positive 3. So, the domain of the function is all values of x such that x is not equal to positive 3. To define the range, let's solve the equation for x in terms of y. Okay, let's solve the equation. We have bring down negative xy is equal now to transpose 3y to the right. That is now negative 3y. Bring down positive 2 and that's plus 2. Then let's divide both sides by negative y. Negative y. So cancel this out. Therefore, we have x is equal now to negative 3y divided by negative y is positive 3y over y, and positive 2 divided by negative 2 is negative 2. Or simply, the equation when solving for x in terms of y becomes x is equal to 3y minus 2 over 2. Now, for x to be real, the denominator y cannot be 0. Okay? It is not equal to 0. Therefore, the range is all values of y such that y is not equal to 0. Okay, let's have number 4. The given is y is equal to the square root of 5 minus 2x. Now, take note. Y is equal to the square root of 5 minus 2x is already expressed for y in terms of x. Since y is a radical, y must be greater than or equal to 0. And its radicand 5 minus 2x must be greater than or equal to 0. Okay? So therefore, let's solve for x. We have negative 2x must be greater than or equal to negative 5. If we divide both sides by negative 2, the symbol of inequality will change. Therefore, we have now x is less than or equal to negative 5 divided by negative 2 becomes positive 5 over 2. Thus, the domain of the function is all values of x such that x is less than or equal to positive 5 halves. Okay, now to find the range given the equation y is equal to 5 minus 2x, let's solve for x. Solve for x in terms of y. So that is y squared is equal now to 5 minus 2x. Remove this and square this. Then y squared minus 5 is equal now to negative 2x. Since we are solving for x, right? Okay. Let's interchange. 2x is equal now to negative y squared plus 5. Divide both sides by 2. Cancel this out. So we have x is equal now to negative 1/2 y squared plus 5 halves. Since the equation x is a polynomial, y can be any real number, right? However, the defining equation is restricted to the values of y that are greater than or equal to 0. And therefore, the range is all values of y such that y is greater than or equal to 0. Now take note, the defining equation is a radical and it is restricted to the values of the radicand that are greater than or equal to 0. That is why the range is all y such that y is greater than or equal to 0. Okay? Thanks for watching. See you on my next video. Bye.